Let's have a look at this example. So it's saying show NC0 minus NC1 plus NC2 minus ... minus 1 to the n. NCn is equal to 0. Now, without looking at the hint, for now, let's look at some features of this identity. It certainly is the addition and subtraction of the coefficients. It's got this additional little minus 1 to the n in it, which might be off-putting for now. You'll get to learn that is a way of introducing alternating signs. If you want an addition on one term and a subtraction on the next, if you raise minus 1 to the n, as n increases, then you'll go from plus 1 to minus 1 to plus 1 to minus 1. So that will be something that you will become more familiar with. And so you can see that you've got the addition and subtraction of the coefficients and is equal to the constant 0. So again, we just see that this does come from a binomial where we had a plus x to the n is equal to, we've got our NC0, and we would normally say a to the n x to the 0 plus NC1 a to the n minus 1 x plus NC2 a to the n minus 2 x squared plus ... with obviously a few things changing in this little pattern. But like I said before, the biggest indicator of what you're going to substitute is this situation where you want a plus x to actually be 0. You can probably work out from that if we were to let a be 1 and x be minus 1, then we would certainly get a 0. I'm just going to pause it and write out the solution now and then come back and talk about it. As you can see, this one comes out very quickly once we recognise the appropriate numbers to substitute for a and x. And in that there's only 2 lines of working, and you can see that if a is equal to 1 and x is equal to minus 1, then we've got NC0, and I didn't put any mention of a in this expression because it's simply 1, and 1 to any power is just going to be 1. However, it is important to include the minus 1 because that to a power will give us a different result depending on the power. So we have NC1 minus 1 to the 1 plus NC2 minus 1 squared, which is a plus 1, and so on up to NC1 minus 1 to the n. Now, simplifying and tidying that up, 0, 1 minus 1 is 0, NC0, we bring that minus 1 to the front, and so it's minus NC1. Now, minus 1 squared is a positive, so we're adding NC2. You can probably see from the pattern the next term would be subtracted and so on. Then depending on whether n is a positive or, an even or an odd number, then minus 1, we'll end up with minus 1 to the n, a plus or a minus, NCn. And so we have shown the identity.